Okay, well, I mean, millions of people have figured this out in hundreds or thousands of different places. This has just been a private example. And what we need is billions of people to do it if we want to solve the problem, because all of these people have managed to take places that were barren and they've turned them into lush areas just full of life, and all of them have restored their soil somehow. Almost none of them have measurements. You just hear anecdotal stories. So I just want to show you a few examples of some of these people who've done that. What we need is large-scale environmental restoration, because that's the best way to stabilize CO2 at safe levels. We'll talk about the science tomorrow. I just want to show some pictures of people who've done that. Carbon, water, and temperature go together. If we stick carbon in the soil, we wind up retaining the water. We wind up growing back the springs and streams. You're going to see some examples of that in what Seth shows. There are many ways to increase and manage soils to increase carbon. We heard some of them earlier, just in the previous session. They come in many forms, and some of the forms of carbon we put into the ground last for seconds before they get consumed. Others last for millions of years. We need to put all of them back. Black carbon in particular, biochar, is the one that lasts the longest. Whoops. We need to manage them with whole watersheds, because we need to trap that carbon in the soil and the water. That at the same time keeps the nutrients on the land, keeps the food healthy. Instead, what we're doing is letting all the nutrients wash away, and we're killing the marine ecosystems, causing harmful algae blooms. So it's really important to manage the land properly and intelligently. This is what they do in Bali, which is a country I do a lot of work in. The Balinese have got the most productive rice agriculture in the world, and what they do is they manage every drop of water. Instead of letting the water rush straight down the hillside, they trap it as high as they can up on the mountainside, and let it run horizontally back and forth, to maximize every bit of productivity they can get out of that water, to trap all of the soil, to trap all of the nutrients. It's the most efficient thing they could have done with that land, and they've made it incredibly productive. Other people could do the same in other places too. I mean, when we do that, when we restore it, we wind up, when we get rain, instead of having all the rain run off like we do quickly and disappear, we retain it much longer. We let it soak into the ground and make it last into the dry season. So, restoring wetlands is another one. I'll mention only very briefly, but swamps and marshes, they build up huge amounts of carbon. We're draining them all, letting all that carbon go off into the atmosphere. But if we restore wetlands, they're incredible carbon sinks, and they're not very hard to do. So we have to reverse course. We need to do what the beavers did. Every river in North America was dammed with beavers. They were driven to extinction by the fur trade. But they slowed down the water and trapped the nutrients and sediments. As soon as the beavers were wiped out, there was masses of sediment and soil washed into the sea. Imitating nature is our best course in making natural systems work more efficiently. And we need to maximize biodiversity when we do it. This is a diagram showing the different forms of life on Earth, with the size of each proportional to the number of species in each group. So we don't want monocultures. We want to grow everything back. Anyway, people have figured out how to do this everywhere. What we need to do is do it on a much larger scale. And Seth will give some examples now from dry lands. I just was mainly talking about forests. That's it for me.